Hello, my dear friends. Hello, my dear friends. Good evening. I hope you are in the live. Hi, Yashwant. Hi, Richard. Hi, Akshara. Hi, Subhana. Still anyone is in live? Hi, Alekia. Still anyone is in live? Hi, Prakash. My dear friends, due to the some net this power issue, I was turning off my camera. Okay, if the hi David, hi Prakash. Hi Alekia, hi Vaishnavi. Now, due to this current issue, I was turning off my camera. Hi Yashwant. If you are having any concern regarding the voice and the video, you just say me. Okay? Like while I was explaining the question or anything display, just you say me. Okay? I was turning off my camera. Hi Srinath. Hi Jasmine. Now we'll wait for the just 1 minute so that the all the students may join the live. Hi, Guru Sai Charan. Hi, Richard. Hi. Right. Now, now let's start our lecture. We'll go with the now, my dear friends. You know, right? If you know the answer, try to give me the answer very fastly. If not, what you have to do? Just give me the question mark. Okay? Right? Now we'll move with the first question. Now, Now, I hope, good evening, Josta. I hope the video is clear. Video and the audio is clear for everyone. Video, audio, is it clear? Right. Now, I hope the video and the audio is clear for you all. I hope the video and the audio is clear. And what is the answer for the first question? My dear friends, be fast. Don't take the much time. Don't take the more than 1 minute. Okay? For each question, try to take the now the answer. Yes. Okay, fine. Now try to solve the question. Richard is saying the answer 4. Good evening, Suraj. Guru Sai Charan is saying 3. Which of the following cannot exist? Cannot exist. Yes. And C2. My dear friends, once you cross check and say me the answer, which of the following is cannot exist? No. My dear friend, already I explained very clearly. Once again, you are doing the mistake. Arre? Which of the following cannot exist? My dear friend, the bond order, if it is equal to 0, if the bond order, if it is 0, that species will not exist. That one will not exist. That one will not exist. Now you cross check which among the following. Okay, Sai Ganesh, you can be focused, and if you are having any doubts, you can ask me. Okay. Now you can see. what is asking? The species which is having the bond order is equal to 0, that species will not be exist in the nature. Option 3. Good, good. Good, Subhana. Good, Suraj Bera. And the first answer was given by the whom? Guru Sai Charan. Guru Sai Charan has already given the option number 3. Good. Good evening, Srinitya. Good evening, Akshara. Yes. Joshita, yes. See, here the number of electrons, He2, right? Now, one electron bond order is 0.5, so it will be exist. Now, He2 plus electrons are 3 and its bond order is 0.5, right? Now, C2 it is having the 12 electron. 12 electron bond order is how much? 12 electron bond order 12 electron bond order is 2, but here the 4 electron, right? 4 electron bond order is 0. If there is no any bond order between the species, how come the He2 will be exist? Already I explained very clearly. Now He2 will not be exist in the nature. That's the reason He will be exist in the nature as a molecule like a He, right? Hi Ajit, hi. Good evening. Right, the answer is 3, my dear friends. If the following species, if they ask which of the following cannot exist, if they ask, you have to be very clear that you have to be very careful that what the one which is having the bond order 0 will not be exist in the nature. Okay, right. Next one. According to the molecular orbital theory, which of the following is true with respect to Li plus, Li2 plus and Li2 minus? Now same. Good evening, Janakiram. Good evening. Now Semi. According to the molecular orbital theory, which of the following is true with respect to Li2 plus, Li2 plus and Li2 minus? Right. Li2 plus and Li2 minus. My dear friends, yesterday itself I said very clearly. Stable and unstable. Option 1. Now more the unpaired electrons in the Li plus 2, right? This is Li2 plus, right? Next one is the Li2 minus. Li2 plus is having the 5 electrons. Li2 minus is having the 7 electrons, right? Now it is having the sigma 1s, sigma star 1s, next sigma 2s, next sigma star 2s. Here sigma 1s, sigma star 1s, next sigma 2s, here the sigma star 2s. Now you can see here 5 electrons, right? 1 2 3 4 5. Now here 1 2 3 4 5 6 7. Clear? Now here you can see the anti-bonding electrons are 2. Here the anti-bonding electrons are 3. Clear? Anti-bonding electrons are 3. Now you can see here the bonding molecular orbitals. We are having what? Bonding molecular orbitals are 4. Here the bonding molecular orbitals are what? Bonding molecular orbitals are 1. Now what I said, if the NB electrons are greater than Na, that it is a stable and it will be exist. But here you can see, here the 2 we are having, here the 3 we are having. Now here the 2 we are having, here the 3 we are having. Next, if you cross check the bond order, if you cross check, 5 electron bond order is 0.5 and the 7 electron bond order is also 0.5, right? Now both the cases bond order is 0.5, right? Both the cases bond order is 0.5. Now both the cases bond order is 0.5. Now what is asking? Li plus 2 is unstable, Li2 minus is stable. Now you say me. Then if the bond order is same, then after the next one, then you have to cross check the which one, the one which is having the higher electrons in the anti-bonding electrons are unstable. So Li plus 2 is stable and the Li plus 2 minus is unstable. Option number 2. Is it clear? You have to cross check in which the less electrons we are having. Clear? In which the less antibonding electrons we are having. Is it clear? Right, Li plus 2 is more stable. You have to cross check in which the less number of antibonding electrons we are having. So the option number 2 is correct. Is it clear? Now option number 2 is correct. Right, good. Yes, right. Now next one. Oh. Next one, in which of the following intramolecular hydrogen bonding is present? Is asking. In which of the following species intramolecular hydrogen bonding? Intra means, now say me the answer. If bonding molecular orbital is not same, what is asking, in which of the following intramolecular hydrogen bonding is present? Is asking, my dear friends. Here chlorine contain lone pair of electron, and here the NO2 nitrogen NO2 contain, this NO2 also will contain lone pair of electron. My dear friends, in the first one, here there is no any chance of forming the hydrogen bonding. There is no any chance of forming the hydrogen bonding, because here also oxygen contain lone pair of electron. In this manner it will be there. Oxygen contain lone pair of electron. In the first one there is no chance. The answer is 2. Good, Suraj, good. Answer is 2. Because already I explained very clearly. What I explained very clearly, hydrogen bonding, hydrogen bonding, hydrogen bonding will shown only when hydrogen attached hydrogen attached with more electronegative elements like fluorine, oxygen and the nitrogen, right? Here the hydrogen, here the in the first option hydrogen only, it is not there. Clear? Now there is no any hydrogen only in the first option. How come the first option will show the hydrogen bonding? Right? Here the fluorine and the hydrogen, it is far away from them. But here the oxygen and the oxygen and OH, it is far away from them. But here the NO2 will be in this manner. Now oxygen, it is having the lone pair of electron, it is having the partial positive negative, and the hydrogen, it is having the partial positive, and due to that it will show the hydrogen bonding, and this one we call it as a intramolecular hydrogen bonding. Already I was given very clearly, right? Now next one, read the question carefully and try to give the answer. Read the question carefully and try to give the answer. Bond order and the magnetic behavior of O2 minus ion R respectively. Is asking bond order as well as magnetic behavior. Both is asking. Bond order as well as magnetic behavior. Bond order as well as magnetic behavior. Bond order is asking as well as what? Option 2. Option 2. Right. Now, Now O2 minus, right? Now O2 minus. O2 minus, it contain how many? 17 electrons. 17 electrons, bond order is good. H1 good. H1 has said first good. Now here 17 electron bond order is 1.5, right? Now already I explained you all odd electrons are para, right? And even electrons except 10 electrons and 16 electrons, all are dia, so this is a 15 electrons, sorry, this is 17 electron. 17 electron will comes under the odd electronic species, and it's a paramagnetic in nature. So 1.5 and a paramagnetic in nature. So the answer option 2. Option 2 is correct. Right? Is it clear? Next one. Now, see the option carefully and try to give me the answer. Don't be in hurry. He is asking which of the following is having the highest dipole moment. Which of the following is having the highest dipole moment? Simply don't give me the answers. Okay? Simply don't give me the answer. Just see the each and every option carefully. Already I explained and I was given the one trick also to identify the dipole moment. Just this is the fourth question. No, I think so. This is fifth question. Okay, my dear. This is fifth question. Now you can continue for the class. Be focused to the class. What is the answer, my dear friends? Anyone who is in the live, try to give me the answer. Anyone? Dipole moment. Everyone are getting difficulty in the dipole moment, I think so. No one is trying to give the answer. Answer 3. No. No. No, 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 no. Arjuna, hi, hi, hi. Answer is 3. Sorry, answer is 4. My dear friends, don't be get confused. Just key point. Whenever the dipole moment, if they have given, my dear friends, whenever the whatever may be the dipole moment question they have given, just a key point you remember. Key point to remember. Key point to remember. What is the key point to remember for the dipole moment question? First key point is, what is the first key point you have to remember? If central atom lone pairs are absent, if central atom lone pairs are absent, right? All are having same type of bonds. All are having same type of bonds. It's a dipole moment. It's a dipole moment. Mu is equal to 0. This is the first point. Okay. This is the first point you have to remember, right? If central atom lone pairs are absent, all are having same type of the bond, it's a dipole moment mu is equal to 0. Next one. Next key point. What is the next key point you have to remember? if central atom lone pairs are absent, if central atom lone pairs are absent and having different type of bonds and having different type of bonds, dipole moment mu is not equal to 0, mu is not equal to 0, right? And if electronegativity difference in bonds increases, electronegativity in difference in bonds increases, dipole moment increases. This is a one key point. This is a one key point. This is a one key point. Next, if suppose the lone pair of electrons are present, if central atom lone pair of electrons are present, lone pair of electrons are present, right? If the central atom lone pair of electrons are present, dipole moment mu is not equal to 0, right? If central atom lone pairs are same, if central atom lone pairs are same, check the more electronegative atoms, more electronegative atoms. Now you see here bf3 its hybridization is sp2 with 0 lone pair, and all are having the same type of the bond, all are having the same type of the bond, fluorine fluorine fluorine. So its dipole moment mu is equal to 0, right? In the first one 0. Next one comes to the nh3. Now in this nh3 the dipole moment vector will be towards the hydrogen to the nitrogen. Why? More electronegative atom and its dipole moment value is 1.48 dBi. Now when it comes to the NF3, central atom having the same lone pair of electron, but here the fluorine, right? Now fluorine being the more electronegative, now its dipole moment vector will be towards the fluorine. Now its lone pair of electron. Clear? Now you see here dipole moment vector, one is towards the lone pair and one is towards the fluorine. Here it will be cancelled out, but here all the dipole moment vectors are in the only one direction, means it is having the highest dipole moment. It is having the almost 0.48 dBi. Means the one which is having the highest dipole moment, NH3 is having the highest dipole. Then after the NF3, then which one? It's a dipole moment 0 only. See, you can see BF3 and next NF3 and the last is the NH3. This is a dipole moment. These are the key points you have to remember. I hope it is clear. I hope it is clear, or still you are having any confusion? It is clear or still you are having any confusion? Ah, I hope it is clear. I think so. Hi, Sonu. Hi. Right. Okay, fine. Now, hmm, read the question. This is for MSET. This is for the mains, and this is for the advanced. This is for the NEET. All for all. MSET, NEET, advanced, mains. All type of the questions are there. All type of the questions. MSET questions, mains questions, NEET questions, advanced questions. My dear friends, try all the type of the questions. Answer is 2. Now, the maximum number of hydrogen bondings that can be formed by one H2O molecule in the ice are. Right. Good. Now, the NEET students are so studious. Very good. Very fastly, the NEET students are saying good. My dear NEET students, we good for you. See, NEET students are so studious. Whatever the answers I was getting, all are from the NEET only. My dear friends from the MSET and my dear friends from the JEE mains, my dear friends from who are studying from the advanced, try to give the answer. See, NEET students are very good. They are so good and they are so studious. They are VVVV good. They are giving the answers very fastly. My dear friends, your mains questions and the advanced questions also they are giving very fastly. So, my dear friends of the JEE mains and the MSET, be fast and try to give the answers. See, actually, the before question was a last year JEE mains question. The before question, not the dipole moment. Before question was the last year JEE mains question. They have given very fastly. My dear friends, the mains and the MSET, try to give the answers very fastly. The NEET students are so fast and they are so studious to give the answer. Okay. I hope it is clear for you all. Right. And once again, we good and maintain the same legacy till the end of the life. My dear NEET students. Right. Right. Done. Now, I hope the competition is between now MSET, mains and the next NEET. We'll see. Sonu, my dear Sonu, I cannot remember you, but I can, by seeing your face, I can remember you, right? Now see the 1H2O molecule, this is the 1H2O molecule, right? 1H2O molecule will form the 4 hydrogen bondings, right? One hydrogen bonding, clear? Now one hydrogen bonding will be from here, right? Now one hydrogen bonding from here, one hydrogen bonding from here, right? One hydrogen bonding from here due to the partial negative of oxygen, right? Here the partial negative. Clear, you can see one water molecule is forming the 4 types of the hydrogen bonding. Sorry here. One water molecule is forming the 4 hydrogen bonding. Right? One water molecule is forming the 4 hydrogen bonding. So the answer is 2. Right. Now clear? Now what is the answer for this one? Which of the following is a correct pair regarding the bond order? Which of the following is correct pair regarding the bond order? Oh, Sonu Nuva. Yes. Sonu, okay, Gurtubatna, my dear friend. Okay, Sonu, okay. Sonu, class, questions vaste chahiye. It will be helpful for your exam. Okay, na? Class vinu, అర్థం చేసుకో, questions వస్తే try చేయి. Okay? Answer is 3. Which of the following is correct pair regarding the bond order? Yes. Now, JEE and James are saying the very fastly for this question now. Yes. Good. My dear beautiful NEET is second now. Right. Good. Now, which of the following pair is correct regarding the is this one? Now you have to say me what is the correct bond orders of this one. What is the correct bond order of O2 plus? What is the correct bond order of O2 minus? And what is the correct bond order of CO2? What is the correct bond order of CO2? And what is the correct bond order of O2 plus? And what is the correct bond order of O2 minus? Now I will see. 1, 2, 3. Now the one who will give the correct option. Yes, my dear friends, good. Now, yes, Sai Vaishnavi has given the 2.5. Right, good. Now the answer has came from the mains. 2.5, good. First, the answer has came from came from Sai Vaishnavi. Next, O2 plus 2.5. Next, O2 minus. Second one, O2 minus is, it is 17, right? 1.5. Second one is 1.5, my dear friend. That is 17. No, no, no. O2 minus. O2 minus is 1.5. O2 minus is 1.5. CO2. 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 Good, good, good. Everyone good. CO2. CO2. What is the bond order? Yes, yes. 2.5, 1.5. CO2. What is the bond order? Okay. Naina Soram. We concentrate to the class. What is the answer for the CO2? CO2, this is now the whatever the bond order trick I was explained, it is applicable only for 20 electrons, right? Now about 20 electrons, the bond order we can calculate in the form of bond order is equal to 1 plus number of pi by number of sigma, right? Now CO2, if you cross check, CO2 we are having the 2, which one? 2 pi and 2 sigma, that it will give you the bond order is equal to 3 plus 2 by 2, that it will give 5, 5 by 2, that will give the bond order is 2.5. Its bond order is 2.5. Right? 2 plus 2, 4, oh, sorry. 2 plus 2 by 2, that it will be 4, 4 by 2, answer is 2, sorry. Bond order is 2. Bond order for the CO is 2. Bond order for the CO2 is 2. Good evening, Lasya. Good evening. Right. The answer is 2.5, 1.5, 2, and it is 3. 2, 2, 2. Yes, 2, 2. Right. Next question. My dear friends, be ready and be focused and try to give me the answer. In which molecule last electron is filled in sigma 2pz? He's asking last electron is filled in sigma 2pz. In which of the following last electron is filled in sigma 2pz? In which of the following last electron will be filled in sigma 2pz? My dear friends, try it by your own. Please, once again, I'm saying don't see or don't search in any Google or don't search in any chat GPT or anywhere. My dear friends, try it from your own. Okay. If you know the answer, try to give. If not, give me the question mark. But don't search in any chat GPT or Google or anywhere. It will decrease your thinking ability. This is sake of for you only. My dear friends, yeah, Akshara, Guru Sai Charan. Last electron is filled in sigma 2pz, amma. Arey, no. My dear friends, the answer is 2. Answer is 2, not sigma 2pz. He is asking last electron. This is carbon, it is having the 12 electrons, right? B2 it is having the 10 electron. N2 it is having the 14 electron. O2 it is having the 16 electron. Now you see, up to 14 electron we have to follow the one bond order, one energy order, that is sigma star 1s. Now sigma 2s, sigma star 2s, next pi 2py, pi 2px, Next, sigma 2pz, pi star 2py. Next, pi star 2px. Next, sigma star 2pz. Right? Now, here carbon 12 electrons, right? Now you see, for the first one I was filling the electron. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Last electron has entered into the pi 2px for the which one? C12. Now B2 10 electrons I was filling. For the B2 10 electrons I was filling. 10 electrons means 1, 2, 3, 4, 5, 6, 7, 8. 8 electrons, right? 9, 10. 9, 10. Last electron is entered into the pi 2py. Next one. Next one, O2. O2, the different energy order, only first in the O2, the energy order, first the electrons will be filled in the sigma 2pz, then only after the pi, right? Up to here 8, 9, 10, 11, 12, 13, 14, here the 15, 16. Last electron has entered into the pi 2px or pi 2py. But nitrogen case, if you check, up to here 8 electron done, right? 10, 11, 12, 13, 14, 15. Last electron is entering into the sigma 2pz, right? Only in the case of nitrogen. Is asking the last electron is filled in sigma 2pz. In which of the following molecule last electron? I hope it is clear. The answer is N2. In the N2, the last electron is filling in the which one? The last electron is filling in the sigma 2pz. I hope it is clear. I hope it is clear for you. Right. Next one. In which of the following both removal or addition of electron leads to decreasing in bond order? Yes. No. See, in which of the following compound both removal or addition of electron leads to the decreasing in bond order? In which compound both removal or addition of electron leads to decreasing in bond order? I was given the very beautiful trick for you to identify the bond order, my dear friends. Yes, good, Yashwant, good, Lasya, good, Akshara, good, Akil, good, Ketan, right, Soram, right. Now you see, if the O2 bond order is 2, O2 bond order is 2. Now if I was added the one electron, it will become O2 minus and its bond order will become 1.5. If I remove one electron, it will become O2 plus and its bond order will become how much? 1.5. Right? What is asking? Here the removal in the compound removal or addition of the electron leads to decreasing in the bond order. Right? Now F2 if you take, both the cases bond order is decreasing. In the F2 case if you take, F2 is a 18 electron. 18 electron bond order is 1. If I add the one electron, 19 electron bond order is 0.5. And 17 electron if I remove, 17 electron bond order is how much? 1.5. 1.5. Now C2 case if you take, C2 bond order is how many? 2. If I add the electron, 13 electron bond order is 1.5. 12 electron bond order is 12 electron bond order is how much? 12 electron bond order is how much? Sorry, 11 electron bond order is how much? 1.5. Right? N2 case if you cross check, N2 case if you cross check, N2 3. If I add 1 electron, 15 electron bond order is 2.5. Next, here also addition of electron also the bond order is became 2.5. Here the bond order is 2.5. Sorry. Yes, O2 plus bond order is 2.5. Here the bond order is 2.5. Here the bond order is 2.5. Both the cases bond order is decreasing. Both the cases bond order is decreasing. Here the bond order is increasing. Here the decreasing. Here the bond order is decreasing. Now here the bond order is 2.5. Sorry. 13 electron bond order is 2.5. 11 electron bond order is 2.5. Yes, only in the case of N2, both the cases electron addition and the removal bond order is decreasing. Yes, my dear friends. Okay, fine. Right, only in the case of N2. Right, good. Next, if the atomic number of the element X is 7, the best electron dot symbol of the element. Indirectly is asking the Lewis dot structure. X element atomic number is 7. 7 elements. 7 element atomic number. Lewis dot structure is asking. What is the answer? Okay. Answer is yes. 7 electrons, right? 7 electrons is nothing but nitrogen. Nitrogen indirectly nitrogen. Lewis dot structure. Nitrogen it is having the 7 valency electrons. So the answer is I Sai Vaishnavi. Okay. Now the answer is 1. Right. The answer is 1. Okay. Good. Good evening, Praneeth. Good evening. The most favorable condition for the formation of ionic bonding. The most favorable conditions for the formation of ionic bond. The most favorable condition for the. Good evening, Praneeth. Good evening. Now be focused to the class and try to give the answer. Be focused to the class and try to give the answer. What is the answer? Answer is 2. My dear friends, already I explained you very clearly about the lattice energy, right? Lattice energy is directly proportional to the charge of cation, charge of anion, and the radius of cation and the radius of anion, right? Now this you have to cross check. This you have to cross check and say me the answer. This you have to cross check and say me the answer. Large size cation, large size cation. Will the large size cation is the size of the cation increases, lattice energy decreases, right? How come the large size cation will form the strong ionic bond? My dear friends, how come the low charges? See, lattice energy is directly proportional to the charge of the cation. Higher the charge, higher is the lattice energy, right? How come the favorable condition? How come the favorable condition will be happen? How come the low charges will be happen, Anna? Once you cross check, uh, already I explained very clearly. Higher the charge and the small size cation, right? Small size cation and the large size anion will form the strong. Lattice energy indirectly is asking the question from the lattice energy. See, lattice energy is directly proportional to the charge of the cation and the charge of the anion. Lattice energy, if it is high, strong ionic bond it will form. Strong ionic bond it will form. Higher the charge, higher is a high charges on the ions and a small cation and a large anion. Large anion is having the higher charge. I explained very clearly, right? Clear? Done? Next, coordinate bond is absent in. Now I will see how many of you will give the correct answer. Coordinate covalent bond is absent in. 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 No. Coordinate covalent bond is absent in. Good, my dear Guru Sai Charan, good. Now the answer is 1. See, coordinate covalent bond means what is the meaning of coordinate covalent bond, Amma? Now, here one lone pair of electron on one atom, on one lone pair of electron on one atom should shared between one lone pair of electron on one atom should shade between what? Shade between two atoms, right? Two atoms. Now you see H3O plus how the coordinate covalent bond will be formed. Normally H2O it is having the two lone pair of electrons, right? Two lone pair of electrons. Now one hydrogen H plus it has came. Now this hydrogen to complete its octet it requires two electrons. Right now the oxygen what it will do, it will donate the electron in the form of the coordinate covalent bond in this manner. When it is donating the coordinate covalent bond in this manner, now what happened, now this lone pair of electron or these electrons are between this hydrogen as well as the oxygen, and this bond represent the coordinate covalent bond. In this manner H3O plus will form the coordinate covalent bond. Now the NH4 plus how it will form the coordinate covalent bond, now we'll see nitrogen in the ammonia, right? This is the ammonia. Now ammonia, here we are having the H plus. H plus it is electron deficient, right? Now this H plus to complete its octet it requires two electrons. Now the nitrogen it is donating the two electrons in the form of the coordinate covalent bond in this manner. That's the reason only nitrogen it is having the 4 bonds and its covalency is the 4. I explained very clearly. Right now you can see it is in between this nitrogen as well as a hydrogen. Right now in the CO3 minus 2. CO3 minus 2 means now here Now here this pi bond represents, now you can see how the coordinate covalent bond in the CO3 minus it is happening. Now this oxygen, here this oxygen it is having the 6 valency electron, right? Now here this oxygen to complete its octet it require 2 electrons, right? Now this carbon it will donate the 2 electrons in the form of the coordinate covalent bond. In the form of the coordinate covalent bond it will be donate, and it is having the which one? Coordinate covalent bond for the CO3 minus 2, right? Now in this manner the CO3 minus 2 it will donate the electron, and this bond represent the coordinate covalent bond. See, 2 we are having the coordinate covalent bond, 4 we are having 3. So in the BH4 we are not having the any covalent covalent bond. That all are the which one? All are the covalent bonds that it has accepted by the empty orbital of the boron. So the answer is 1. So you have to be very careful with the coordinate covalent bond. My dear friend, they are repeatedly they are asking the questions from this one. I hope it is clear. Done. Next one. Among the following ions, the p pi d pi overlapping could be. He is asking only p pi d pi. Which of the following ions the p pi d pi overlapping could be? In which of the following only the p pi d pi overlapping is present? In which of the following the p pi d pi overlapping is present? In which of the following case the p pi d pi overlapping is present? Anita is saying it is 4. Anita, it is saying 4. Who? Now, already I explained you very clearly that first find the hybridization. NO3 minus hybridization. Normally, nitrogen it is having the 5 and it is having 2. Now, sp2 hybridization means one pure p orbital will be there. So, oxygen always will form only the p pi. So, here the pi bond formed is the p pi p pi. Right? Next one, here we are having the CO3 minus 2, CO3 minus 2, carbon, it is having the 1, 2, 3, 4, 5, 6. Clear? Here the 3 oxygens. Here also sp2. Now here also sp2. Now here the NO2 minus 1, 2, 3, 4, 5, 6. Here the 2 oxygens. Here the S, here the P, here the P. Now already I explained very clearly. sp2 hybridization means 1 p pi p pi. Now here the hybridization is what? sp3. sp3. sp3 means 0, 0 p pi p pi. 0 p pi p pi means with the whatever the pi bonds we are having, that is of the p pi and d pi only. So the option number 2. Just to see the hybridization, if it is came the sp2, if the hybridization if it is sp2, then 1 p pi p pi. If other than sp2, then you can cross check. My dear friend, negative charge on the central atom indicates that it has gained 1 electron. Negative charge on the central atom indicates that it has gained the electrons. It has gained that electrons. Right? Now, next one. The number of bonds and the lone pairs in SO2. Number of bonds as well as lone pairs in the SO2. Number of bonds and the lone pairs in the SO2. Number of bonds and the lone pairs in the SO2. Negative charge indicates that it has gained the electrons. How many negative charges are there? That many electrons it has gained. What is the answer for this one? The number of bonds and lone pairs on the SO2. Answer is 3. Yes. See, SO2, right? Sulfur, it is having 6 valence electrons and 2 oxygens. 2 oxygen, this is S, this is P, and 1 lone pair, right? 1 lone pair. Now SO2 will contain in this manner. Now 1 sigma, 1 pi, 1 sigma, and 1 pi, 1 lone pair. 2 sigma, 2 pi, 1 lone pair. Good. 2 sigma, 2 pi, and 2 lone pair. Right. Next one. Next one. The shape of CH3 plus species is. The shape of CH3 species is. The shape of CH3 plus 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 species is. SO2 is polar. What I said, if the central atom, if it is having the lone pair of electron, blindly believe that is polar. This is polar. The answer is 3. Answer is 3. Carbon, it is having 3. Here the hydrogens. Now this is S, this is P, and this is P. This is sp2 with a 0 lone pair. sp2 with a 0 lone pair, it is a trigonal planar, my dear friend. sp2 with a 0 lone pair, trigonal planar. It is not. Right. Now answer is trigonal planar. Next. According to the Fajan's rule, the covalent bond is formed by. Now according to the Fajan's rule, the covalent bond is formed by. Now according to the Fajan's rule, the covalent bond is formed by. According to the Fajan's rule, the covalent bond is formed by. We have completed still now 20 questions. This is 20 to 21 question, I think so. 21 questions. Still more 15 questions are there. Be fast. By 8:30, max to max, by 8:30 I will finish. By max to max 8:30 I will finish the questions. Up to now 20 questions we have done by covering all the concepts: hybridization, lattice energy, covalent character, dipole moment, bond angles, everything. Answer, according to the Fajan's rule, the covalent bond is favored by. Covalent bond is favored by. My dear friend, answer is 4. Already I explained, right? Small size cation, and large size anion. Small size cation and large size anion will have high covalent character. High covalent character. Small size cation and the large size anion. My dear friend, you have to be very careful. No. You are saying reverse. Small size cation and the large size anion is having the high covalent character, and this is favorable for the. This is favorable for the which one? Ionic bond. Sorry, covalent bond. Good. Right. Next one. Which of the following has zero dipole moment? Which of the following is having zero dipole moment? Which of the following is having zero dipole moment? Which of the following is having zero dipole moment? This is CLF. One is PCl3, CLF3. This is SiF4. Which of the following is having a zero dipole moment? Which of the following is having zero dipole moment? Yes, good, Anita, good, good. Now the zero dipole moment it is having for the SiF4. No, already I explained you clearly, my dear friends, why you are getting confusion. I was not understanding. Zero dipole moment, just to cross check the central atom lone pair. Central atom lone pairs are zero and same type of bonds and same type of bonds. Dipole moment mu is equal to 0. Dipole moment mu is equal to 0. Now the CLF, in the CLF, chlorine contain 3 lone pair of electrons. Chlorine contain 3 lone pair of electron. In the PeCl3, phosphorus contain 1 lone pair of electron. And CF3, what I said, lone pair of electrons are absent, but there is a different type of the bonds. If the different types of the bonds, if it is having dipole moment not equal to 0. If the lone pair of electrons are present on the central atom, dipole moment not equal to 0. Clear? Here the dipole moment is not equal to 0. But here the central atom does not contain lone pair and it is having the same type of the bond and the dipole moment is 0. Option number 3 is correct. Option number 3 is correct. According to the molecular orbital theory, O2 plus possess. According to the molecular orbital theory, O2 plus possess. According to the molecular orbital theory, O2 plus possess. Nothing is there, my dear friends. Only central atom lone pairs are 0 and same type of the bonds are having dipole moment mu is equal to 0. That's it. Just you remember this point. Here in the PCl3, we are having one lone pair of electron. Here this is a PCl3. It is having one lone pair of electron. In the next one, if the central atom having 0 lone pair but different types of the bonds are there, then also dipole moment is not equal to 0. Then also dipole moment is not equal to 0. Now in the CLF3, chlorine it is having the 3 lone pair of electron. Central atom, if the lone pair of electrons it is having, dipole moment is not equal to 0. Now what is asking, according to the molecular orbital theory, O2 plus possess. O2 plus possess bond order 2.5, 3 unpaired electrons. No, only one unpaired electron will be there. Only one unpaired electron. Now diamagnetic in nature. No, it is paramagnetic in nature. Stability is lower than the O2 minus. No, stability is higher than the O2 minus because O2 minus is having the 3 anti-bonding electrons. It is O2 minus, O2 plus is having only one anti-bonding electron. Like if you cross check after the 14 electrons. Right, the answer is 1. Which of the following is not paramagnetic? He's asking which of the following is not paramagnetic. Which of the following is not the paramagnetic? Which of the following is not the paramagnetic? My dear friends, I was not able to understand the viewers who are watching. I was getting in between 20 to 25 frequent viewers are watching. Frequently, maximum to maximum, frequently 15 to 20 students are frequently they are watching. But the answers I was getting only from the 6 to 8 or below, less than 10 students the answers are getting. My dear friends, if you watch simply, just try to interact. so that I to get to know the one who is interacting. I can say by your sake also, like you up to your level also. My dear Richard, try to give me the answer. Now you are giving very late. Only for the few questions you are giving the answer. Now the answer they are saying it as a 3. Which is not the paramagnetic asking? Which is not the paramagnetic? O2 16 electron para. O2 minus 18 electron it is a dia. O2 plus it is 15 electron para. O2 minus 17 electron para. Here para. Now this is O2 minus it is a dia. So option number 3. Good, my dear friends. Good. Everyone. Right. Read the each and every option carefully and try to say me the answer. Read the each and every option carefully and try to give me the answer. Read the each and every option carefully and try to give me the answer. Read the each and every option carefully and try to give me the answer. Which of the following is not correct from the viewpoint of MOT? From the MOT, which is not correct? Answer is 2. Not correct is asking. My dear friends, cross check is asking which of the following is not correct. Be2 is not stable molecule. That is correct. He2 is not stable. He2 plus is expected to exist. That is also correct. Then the bond strength of N2 is maximum amongst the homonuclear diatomic molecules belong to the second period. That is also correct. But the last one is the order of the molecular energy order. Now the first here they see sigma 2pz they have given first. Actually first pi should come, then only after the sigma it should become, right? Now the homonuclear means same. Homo means same. Homo means same. Like H2 homo, N2 homo, O2 homo, F2 homo, right? Hetero means like HCl, different, two different HCl. Now SO2, CO2, clear? These are hetero. These are hetero. Homo means same type of the atoms. B2, C2, these are homo. HCl, SO2, CO2, these are okay. These are hetero. I hope it is clear. I hope it is clear. Okay. The answer is 4. Here the list of the molecules. Here the molecules they have given. Molecules they have given, and he is asking the bond order. Try to match the bond order and say me the answer. Try to match the bond order and say me the answer. Just to find the electrons, and we know the trick, right? Just to give that answer. Answer is 2, 2, 2, 2, 2, 2, 2. Li plus 2, 6 electron, bond order is 1. Right? N2, 14 electron, bond order is 3. B plus 2, B 8 electron, bond order is 0. O 16 electron, bond order is 2. So first one is C. Second one is A. B to D. Bond order E. So 1C, A, D, E. So option number 2. Good. Good, my dear friends. Good. The correct NO bond length in the given species is the correct NO bond length. My dear friends, this NO bond length you can identify by the which one? Hybridization. We know hybridization. SP bond angle 180. From the bond angle you can cross check. SP2 120, SP3 109 degree, 28 minutes. Right? Next one. SP3 with one lone pair. SP3 with one lone pair 107. SP3 with two lone pair 104.5 degrees. Now from the bond angle you cross check. From the hybridization you cross check and same the answer. Hmm. 2. NO plus bond order is SP. NO plus bond order is SP. Here NO2 minus bond order is how much? SP2. Here the NO3 bond order is how much? Here the NO3 bond order. Here the how much? 1, 2, 3, 4, 5, 6. Here it is the SP with one lone pair SP2. Here 1, 2, 3, 4, 5, 6. Here also SP2 with a 0 lone pair. SP2 with a 0 lone pair. So here the 2 should be high. Then after the SP2 with a 0 lone pair, then on. So the option number 4 is correct. Option number 4 is correct. My dear friend, option number 4 is correct because SP, this is SP hybridization, right? SP will have 0 lone pair. SP will have the highest bond length. SP high bond angle, less bond length. Oh, sorry. He's asking bond length, right? Bond length. He's asking the bond length. Bond length means bond angle if it is high, bond length will be less. Bond angle if it is high, bond length will be less. 2 should be last. 2 should be last. And 2 should be last. And here the answer. Then after that 4 SP2. This is SP. So the answer is 3. sp3. Now the NO it is having, like NO will be exist, NO hybridization. My dear, NO hybridization, it is having the coordinate covalent bond. Coordinate covalent bond will be there in the NO. Coordinate covalent bond will be there in the NO. It will be exist in this type. Coordinate covalent bond will be there in the NO. Right. In this manner, the coordinate covalent bond will be there. It will be exist in this nature, NO. And its hybridization is sp. Its hybridization is sp. Answer is, here the hybridization we cannot predict, but according to the Lewis dot structure we can say. According to the Lewis dot structure we can say. This is a Lewis dot structure of the NO. Okay, right. In which conversion bond length is decreasing? My dear friends, you have to be very careful. In which conversion bond length is decreasing? You can see bond here from the year to year bond order increases. Year to year the bond order increases. Bond length decreases. That you cross check. That's it. Cross check the bond orders and try to say me the answers. Cross check the bond orders and try to say me the answers. Cross check the bond orders and try to say me. If the here this piece is bond order and this piece is bond order, from year to year the bond order increases, bond length decreases. That's it. That you cross check and say me the answer. Should I explain? My dear friends, be fast. Be fast. See, here the bond order is 3. Now N2 plus bond order is 2.5. Clear? Now bond order decreases means bond length increases. Now here it is a 3. Here it is a 2.5. Bond order decreases means bond length increases. Here CO. CO, this is exception. Already I explained you very clearly. Very clearly I explained you this molecule. Option number 3. Option number 3. CO bond order is 3. CO plus bond order is 3.5, right? I explained very clearly this is CO plus is exception. Exception and its bond order is 3.5. From 3 to bond order 3.5 is increasing. Bond order is increasing means bond length will be decreased. O2 bond order is 2. Now here the O2 minus bond order is 2.5. Here also O2 minus bond order is 1.5. O2 order 1.5. Bond length decreases mean bond order decreases means bond length increases. Only option number 3 is correct. This is very important. You have to be very careful with this one. See, this is CO plus is exception. Right. The correct shape and the hybridization of SeO2. The correct shape and hybridization of SeO2. The correct shape of SeO2. Now here the selenium. Selenium, it is having the 6 valency electrons. 1, 2, 3, 4. And oxygen it will take the 2. And fluorine it will take. This is S. This is P. This is P. and it is P. So this is sp3 with one lone pair. sp3 with one lone pair, that is trigonal pyramidal. sp3 with one lone pair, trigonal pyramidal. Right? Right. Now I will ask you one question. Now you have to say me, my dear friends, that what is that question? Here the CH3, here the CH double bond, here the C triple bond, C, and here it is a CH3. My dear friends, what is the first carbon hybridization? What is the second carbon hybridization? What is the third carbon hybridization? What is the fourth carbon hybridization? What is the fifth carbon hybridization? What is the first carbon hybridization? What is the second carbon hybridization? What is the third carbon hybridization? What is the fourth carbon hybridization? What is the fifth carbon hybridization? No, no, no. Questions are there. Questions are there. No, questions are there. My dear friends, questions are there. Now, the first one is sp3. We know three hydrogens and one sigma. So, three sigma bonds and one sigma bond for total hybridization number sp3. Now, first carbon hybridization sp2. Second carbon hybridization is sp2. Third carbon hybridization 1 sigma, 2 sigma. So hybridization number sp. 1 sigma, 2 sigma. This hybridization is sp. Now this carbon hybridization is sp3. This carbon hybridization is sp3. Fourth carbon is sp. My dear friend, fourth carbon is sp. Fourth carbon is not sp2. Fourth carbon is sp. Fourth carbon is sp. Okay. Now next question. The next one question I want to ask you, that LiCl, NaCl, KCl, and CSCl. Now, from high covalent character to less covalent character. High covalent character to less covalent character. High covalent character to less covalent character. 1, 2, 3, 4. High covalent character to less covalent character. My dear friends, say me. High covalent character to less covalent character. High covalent character to less covalent character. Use the Fajan's rule. Use Fajan's rule. Use Fajan's rule. Use Fajan's rule and saving. Use the Fajan's rule and saving. 1 greater than, 2 greater than, 3 greater than 4. High covalent. What I said. Small size cation required, right? Small size cation. Small size cation. Right. 1 greater than, 2 greater than, 3 greater than 4. Because Li plus, Na plus, K plus, Cs plus. Now, top to bottom, covalent character increases. Top to bottom, covalent character what? Increases. Now, next question I want to ask, that is DSP3 or sp3d2. DSP3 or sp3d2. Now, hybridized orbitals involved are both are same only, dsp2 sp3 both. What are the hybridized orbitals involved here? What are the hybridized orbitals involved here? My dear friends, questions are there. Don't move. Here we can see the questions are there. Questions are there. Okay. Now, what are the hybridized orbitals? What are the hybridized orbitals involved in the sp3d? What are the hybridized orbitals that are involved in the sp3d2? What are the hybridized orbitals that are involved in the sp3d2? Hybridized orbitals means like this, like s, px, py, pz, now dz square and dx square minus y square. These are the hybridized orbitals. No, 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 not like that, not like that, not like that. Here, what are the hybridized orbitals means? These are px, py, pz, sp3d2 and the dsp3. Now the hybridized orbitals involved are dz square plus dx square minus y square. That's what I was asking. Yes, yes, yes. Good, 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 good. Good, my dear friends. Good. Right, right, right. Yes, yes. Now, next, I want to ask you one very interesting question. That what? Now, here the mu is not equal to 0 in which of the following species? Dipole moment is not equal to which of the following species? Dipole moment is not in which of the following species? Dipole moment is not equal to 0 in which of the following species? This was I was explained very clearly in the class also. sp3 means hybridization, my dear friend. In which of the following species dipole moment mu is not equal to 0? In which of the following dipole moment mu is not equal to 0? This is very, very important question. 1, 2, 3, 4. My dear friends, only one thing you remember. If lone pair present on atoms, dipole moment mu is equal to 0. If lone pair present on atom, dipole moment mu is not equal to 0. So here the two lone pairs will be there. Here the two lone pairs will be there. Mu is not equal to 0. Here the two lone pairs will be there. Here the two lone pairs will be there. Dipole moment mu is not equal to 0. Here 0 lone pair. So dipole moment mu is equal to 0. Here the chlorine, this lone pair of electrons are present in pure p orbital. Pure p orbital. What is the meaning of the pure p orbital? Pure p orbital, it is symmetry. Symmetry, and the dipole moment vectors will be cancelled out. Here also mu is equal to 0. Only dipole moment mu is not equal to 0 in a third option and the fourth option. Third option and the fourth option, dipole moment mu is not equal to 0. Third and the fourth, dipole moment mu is not equal to 0. Clear? Now the dipole moment is equal to 0. Third and fourth. Good, 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 good. Dipole moment mu is not equal to 0 in the third and fourth. Next. My dear friends, now you have to say me that next one question I want to ask you, that suppose AsF5 they have given, AsF5 they have given. Now, what is the hybridization? What are hybridized orbitals involved? What are the orbitals involved? What are the orbitals involved? What are the orbitals involved? Like S, Px, Py and Pz. Which D it has used? Which D it has been used? Which D? Which D it is having the hybridization? What is the hybridization and which D orbital it has used? See me? No, this AsF5 means arsenic, right? Arsenic it is comes under the sp3d, right? sp3d. sp3d. Hybridization, it is sp3d, and geometry is trigonal bipyramidal. Trigonal bipyramidal, it's that is dz square orbital. Dz square orbital. You have to be very careful with this one. Dz square orbital. It will comes under the dz square orbital. Right. Good, good, good. Next, here, now, here, my dear friends, which of the following does not contain pi bonds? I mean, which of the following is not having pi bonds? No pi bonds. NO2, H2O, and CSO2, and D, SO3. Which of the following is not having? Which of the following is not having? What, my dear? What I have to explain? What I have to explain? May I know what you are asking? Explain, sir. What I have to explain? That Babita ji, what I have to explain? sp3d. In the sp3d, the orbitals used are dz square only. In sp3d2, sp3d2, yes, px, py, and pz, and dz square, and dx square minus y square. These are the orbitals. Now, no pi bond in. Answer is B. Good, good, my dear friends, good. No pi bond is in the H2O. H2O, there is no any pi bond. H2O, there is no any pi bond. H2O, there is no any pi bond. Good, good, good. The last question are the only few questions it is having 2-3 questions. Now here, which ion conduct electricity more from the higher to lower? Which ion will conduct electricity? Which ion will conduct electricity more? Now among the 5 ions, 1, 2, 3, 4, 5, which ion conduct electricity in which ion conduct electricity in H2O? Which ion will conduct electricity in H2O? Means which ion will move very freely in the H2O will conduct the electricity, my dear friends. Which ion will move in the H2O freely, that ion will conduct, that ion will conduct, that ion will conduct current very freely. What is the answer? Good, 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 Babita ji, good. No, the answer is CS plus. CS plus will move, CS plus, RB plus, next K plus, Na plus, and Li plus. Now I will explain, listen. Here, this one, now Na plus is a small size, right? Na plus is having the small size. Now in the H2O, H2O molecule will be surrounded like this. H2O molecule will be surrounded to the Na plus like this. Now when the H2O molecule is surrounded with the Na plus like this, Na plus is not having chance to move, not having chance to move. Clear? Now the CS plus or Li plus being the small size, more the water molecule will be occupied. More the water molecule will be occupied like this. Right? Now the CS plus being the bigger size, now you can see CS plus being the bigger size. Now here the H2O, here the H2O, here the H2O. Less water molecule will be occupied to the CS. So the less water molecule has been occupied to the CS. CS is freely moving. Freely move and conduct electricity. Conduct electricity. I hope it is clear. Conduct electricity. Right. This is having some moment. Next one. The next one. You can see he is asking which of the following species will have the intramolecular hydrogen bonding. Which one is showing the intramolecular hydrogen bonding? Which of the following will show the intramolecular hydrogen bond? Which of the following will show the intramolecular hydrogen bond? Which of the following will show the intramolecular hydrogen? I hope the picture is clear. I hope the picture is clear. Which of the following will show the intramolecular hydrogen bonding? No, no. He is asking just which one will move very freely in the solution and which of the following will show the intramolecular hydrogen bonding, my dear friend? You can see here itself it is having, right? Carbon it is having the negative charge, oxygen it is having the one it will show, right? One it will show. One it will show, right? One it will show and the four also will show. One it will show and the four also it will show. One or five, yeah. 194, 194. 194, 194. 194, 194 is having the intramolecular hydrogen bonding. This one, ICl5 and ICl4. Last question, my dear friend. Last question. Now I will end the session here. Just one and two questions are there. Just one and two questions are there. By that, I will end. Only one and two questions are there. Only one and two. Now, what is the answer for this question? Answer is 4. 4. See, ICl, right? Iodine contain 7 valency electron. Right? Here the Cl, here the Cl, here the Cl, here the Cl, here the Cl. S, P, 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 D. Now this is one lone pair. This is D. sp3 D2 with one lone pair. With one lone pair. ICl4. ICl4. ICl4 1, 2, 3, 4, 5, 6, 7, 8. Here the chlorines are 4. This is S, P, P, P. And here one lone pair D. And here it one lone pair D. So sp3 D2 with a two lone pair. ICl5 is having the what? Trigonal bipyramidal. No. It is having the square pyramidal. ICl5 is having the square pyramidal. ICl4 is having the square planar. So option number 3 is correct. Good. Answer is 3. Yes, my dear friends, answer is 3. This one, XeF5 and XeOF3. But I want to this answer, try to give me, my dear friends, try to give me this answer in the comment section. This answers, my dear friends. Actually, I will show you the questions, my dear friends. Actually, the time is more. We have expected to stop the live up to only 8:30, but we are having some plenty of the questions. I will show you the questions. Those questions answers you give me in the comment section. I will cross check over there. I will give you the numbers like this. Question number 1. Now this is a question number 2. Okay. Now my dear friends, you can cross check. This is question number 2. Now this is question number 3. Okay. Now this is a question number 3. Now next one, this is a question number 4. Okay, this is a question number 4. Okay, next this is a question number 5, right? Okay, now next one, this is a question number 6. My dear friends, the 6 questions has left. Only the 6 questions has left, because you have to balance the other 2 subjects also. It has becoming late for you. I have showed the 6 questions, right? Just those 6 questions answer you just give me in the comment section. I will cross check over there. Okay, I will see who one will give you the first answers for those 6 questions, and those comment will be pinned. I will see whether the beautiful BPC or gems mains are the excellent what excellent MSET. We'll see. Okay, my dear friends, should I end the live? I will see whose comment will be in the first. My dear friends, pi bond will be there in the NO2. Why not the pi bond will not be there in the NO2? NO2, the pi bond will be there. This is the NO2 structure. This is the NO2 structure. Okay, my dear friends, try to give me the answer. Okay, 6 questions I was showed, right? That 6 questions answer, try to give me in the comment section. Okay, my dear friends, see you tomorrow. All the best, and be studious and be concentrate on the questions and the other 2 subjects also. Okay, should I end the live? Should I end the live? My dear friends, should I end the live? Good night, everyone. Good night. Good night. My dear friends, try to give me the answers of those questions. Okay, the answers which I was showed. My dear friends, almost the 25 to 30 questions I was did earlier. It is nothing, Mama. This is just actually I was writing on the pad, right? I was on the right pad, right? It will helpful to not to get any pain here. Nothing is just hand gloves. This is the pen hand glove, nothing. Right, right. Okay, my dear friends. See you tomorrow. Bye. Nothing. It is just hand gloves.